Hello class, this is lessons 8-5 and 8-6 about radical expressions. And sometimes when we take the square root of a number, we find that it's not a perfect square. And so there's a rule that if you can break it into two different numbers being multiplied, that you can do the square root of a times the square root of b. For instance, the square root of 63. I can think to myself, oh, well, that's 9 times 7. So following my rule, that's the square root of 9 times the square root of 7. The square root of 9 is 3, so this turns out to be 3 radical 7. So let's go ahead and do some examples where we are following this rule. But it might be helpful to recall all of those perfect squares that we learned in our last lesson, such as 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So if I can think, is this one of these perfect squares times something else? It'll be a lot easier. For example, square root of 180. Well, I could ask myself, is this one of those numbers times something else? It is. This is actually 36 times 5. I know the square root of 36. It is 6. So my final answer is 6 radical 5. Easy. Let's do another one. The square root of 675. So this one is 225 times 3. The square root of 225, if you recall, is 15. So my final answer is 15 radical 3. Next one is the square root of 320. So this is going to be 64 times 5. The square root of 64 is 8, so it's going to be 8 radical 5 for my final answer. For our next example, let's do something even bigger. Let's find the square root of 1,300. Well, this is the same as 100 times 13. And square root of 100 is 10, so my final answer is 10 radical 13. Piece of cake. So really knowing those perfect squares comes in handy. Let's do one more like this. Let's do the square root of 392. So going back to the perfect squares that I memorized, this is the same as 196 times 2. Square root of 196 is 14, so my answer is 14 radical 2. Now some of our problems today are going to involve some variables as well. So our next problem is to find the square root of 24v squared. So again, I'm going to break this up so that it is the square root of 4 times 6 times v squared. Square root of 4 is 2, square root of v squared is v, and I'm left with radical 6. Okay, let's do another one. Let's find the square root of 176a squared. So this time 176 is the same as 16 times 11 times a squared. Square root of 16 is 4, square root of a squared is a, and I'm left with radical 11. All right, here's another one. Let's find the square root of 50w cubed. So 50 is the same as 25 times 2, and w cubed is w squared times another w. So I can find the square root of 25, which is 5, and the square root of w squared, which is w, and I'm left with 2w locked inside of my radical symbol. Okay, let's go ahead and do one more before we move on. Let's find the square root of 72u to the 4th power. So 72 is the same as 36 times 2, and then I still have my u to the 4th power. Square root of 36 is 6, square root of u to the 4th is u squared, and I'm left with radical 2. So hopefully this made sense. Now we're going to move on to if we have a fraction inside of our radical symbol, and we can separate this by doing radical A divided by radical B. So our first example is the square root of 11 fourths. So again, separating it, it's square root of 11 over square root of 4. And there's nothing that I can do with radical 11, so I'm going to leave that on top, but square root of 4 is 2. So my final answer is radical 11 over 2. All right, let's go ahead and move on. Our next example is the square root of 36 over 49. So I'm going to separate this to be radical 36 over radical 49. Square root of 36 is 6. Square root of 49 is 7. My final answer is 6/7. So that one was really nice. There's no more radical in my final answer. Here's another one. This time I have radical 32 over n squared. So we're going to involve some variables. I'm going to go ahead and separate it. And again, radical 32 is 16 times 2 over n squared. So I know the square root of 16 is 4, and I'm still left with radical 2. Square root of n squared is just n, so there's my final answer. Let's go ahead and do 2 more examples. This next one is the square root of 147 over 9x squared. So let's separate it kind of into 2 problems. Square root of 147 over the square root of 9x squared. 147 is the same as 49 times 3. And I know that I can just separate that as 9 times x squared. And I have 3 terms that I can take the square root of. So in the end, I'm left with 7 radical 3 over 3x. Now that 3 and the radical 3 cannot cross cancel because the radical 3 is kind of trapping it inside. So just take note for that. Our final example is going to be x squared y cubed over z to the 4th power, and I'm going to take the square root of that. So I'm going to go ahead and separate these to take the square root of x squared y cubed all over the square root of z to the 4th power. So on top, I'm left with x squared times y squared times just another y, all divided by the square root of z to the 4th power. So I can find the square root of 3 of my terms, so I'm left with xy radical y divided by z squared. And that's it. All right, let's go ahead and move on now to another type of problem where you would have a number times the square root of, let's say, a, plus a different number also times the square root of a. If that's the case, you can add those outside numbers and multiply them both by the square root of a. So it only works if whatever's inside of the radical is matching. So in this first example, I have 4 radical 5 minus 2 radical 5. So that leaves me with 2 radical 5. I also have 3 radical 7, which I can add to 7 radical 7 to leave me with 10 radical 7. So my final answer is 2 radical 5 plus 10 radical 7. In my next example, I can see that the first term and the last term both have radical 19 involved. So 17 minus 3 is 14. So that simplifies to 14 radical 19. The inner terms are negative 14 radical 6 plus 11 radical 6, which gives me negative 3 radical 6. And that is it. Now looking at this third example, I don't have any terms with the same radical symbol, but maybe I can rewrite them so that they have some matching terms. So for instance, I know that 75 is 25 times 3. Also, I know that 48 is 16 times 3, and I know that 27 is 9 times 3. So I can take the square root of 25 and the square root of 16 and the square root of 9 so that I have 3 times 5, which is 15 radical 3. And I have negative 6 times 4, which is negative 24 radical 3. And then I would also have minus 3 radical 3. And so now that all three terms have radical 3, I can have 15 minus 24 minus 3 to give me negative 12 radical 3 for my final answer. All right, let's move on to this bottom example now. Again, none of the radical symbols match, but I know that 50 is 25 times 2. I also know that 32 is 16 times 2, and 8 is 4 times 2. So I can take the square root of 25 and the square root of 16 and the square root of 4 to simplify this expression. So I have negative 11 times 5, which is negative 55, radical 2. 2 times 4 is 8, radical 2. And then negative 18 times 2 is negative 36, radical 2. And so when I combine negative 55 plus 8 plus negative 36, I get an answer of negative 83 radical 2. And that's my final answer. So this is how we added radical expressions. To wrap up this lesson now, we're going to learn how to multiply radical expressions. For instance, if I had a radical b times c radical d, I would multiply the outside numbers, and then inside of the radical, I would multiply the inside numbers. So in my first example, I have 5 radical 3 times 4 radical 6. So on the outside, I'm going to multiply 5 times 4, and then on the inside, I will multiply 3 times 6. This gives me 20 radical 18, and radical 18 can be simplified to the square root of 9 times the square root of 2. And I know the square root of 9 is 3, and 20 times 3 is 60, so my final answer is 60 radical 2. All right, let's look at our next example, 3 radical 10 times negative 9 radical 6. So again, I'm going to multiply my outside numbers, 3 times negative 9, and then on the inside, I will multiply 10 times 6. This gives me negative 27 radical 60, and I know that 60 is the same as 4 times 15. And the square root of 4 is 2, so negative 27 times 2 is negative 54, and I'm left with radical 15. Now, you might come across some examples where you need to use the distributive property, like in our next example. We're going to multiply 4 radical 7 times 2 radical 8, and then 4 radical 7 times 3 radical 7. So I'm going to go ahead and write that for you right here. And in the end, we'll be adding those together. So now, like we did before, let's multiply the outside numbers. 4 times 2 is 8, and on the inside, 7 times 8 is 56, plus 4 times 3 is 12, and 7 times 7 is 49, so that's 12 radical 49. And now I need to add these together, but since the radicals don't match, I'm going to try to simplify to see if anything can be combined. And I know that 56 is 4 times 14, and I know the square root of 49 already, that that's going to be 7. So this is going to be 8 times 2, which is 16, and I'm left with radical 14. And then 12 times 7 is 84. But they don't have matching radicals, so this is as far as we can combine it, and we are done. All right, we have one final problem. Let's use the distributive property again. So that's negative 4 radical 6 times 7 radical 12. And negative times negative is a positive, so that's going to be plus 4 radical 6 times 4 radical 8. And this, when I multiply, I get negative 28 radical 72 plus 4 times 4 is 16 radical 48. Again, my radicals don't match, so I'm going to see if I can simplify them any more. I know that 72 is 36 times 2. And I also know that 48 is 16 times 3. So this can be rewritten. If I multiply negative 28 times 6, I get negative 168, and I still have the radical 2. And then 16 times 4 is 64, and I'm still left with the radical 3. So again, this will be my final answer because I cannot combine them any further, but we are done. And I know it was a long lesson, but please let me know if you have any questions when you come into class.